Hi everyone, Assalamualaikum. Today we will continue on the inverse Laplace transform for part 2. In this topic, I will continue on the Cauchy property and we will also touch a little bit about the partial fractions. Okay, let's do some recall. In previous example, we have learned about the finding inverse Laplace transform by using Cauchy property. Okay, so for example, we have inverse Laplace of 6 over s minus 1 power 2 minus 9. Right, it is easy to solve this one because this pattern we can see that it is quite similar to the table, which is equal to sin hat, because we have the pattern of a over s square minus a square. For s, it is attached to minus 1, so means we can solve this one by using Cauchy property. Okay, so we can simply claim this one as a fs minus a. Okay, so our a is 1 here. Okay, so because every single s is attached to the minus a, right? So since we have fs minus 1, so we can find fs. Fs means we need to substitute all the value of s minus 1 in the equation into s. So the answer will be 6 over s square minus 9. Okay, so from fs we can find ft, which is equal to inverse Laplace of fs, so equal to 6 over s square minus 3 square. Okay, so to get this form, okay, so I bring this one first. So we get 6, okay, inverse Laplace of s square minus 3 square. Okay, so since 3, I want it to be up here, so we put back over 3. Okay, so the answer will be 2. 3 over s square minus 3 square is equal to sin h 3t. Okay, this is our ft. So copy back the question back. So we know that 6 over s minus 1 power 2 minus 9 is equal to finding inverse Laplace of fs minus a. Okay, so in our example, it is equal to s minus 1. So inverse Laplace of s minus 1 is equal to EATFT. So our E will be equal to A equal to 1. So ET, and FT, our FT is equal to 2 sin h 3t. Okay, so the solution will be 2ET sin h 3t. Right? So this example is quite easy for us because the pattern, the question here is quite similar with the pattern inside the table. Okay, and then the s here are already in the factorized form and it is attached to minus constant. So how about if we have the complex function such as we have 3s minus 5 over 4s squared plus 4s plus 1, where it is in the form of quadratic. Okay, so how to rearrange until we get we can get in the form of s minus a. In this example, we will try to solve the quadratic form using the Cauchy property. Okay, so we will use the completing the square in order for us to rearrange the equation so that it can be equal to s minus something. Right, so the formula is given by this form. Okay, in this form we have s square plus bs plus c, so we just have to determine what is b and c, then we substitute into the formula. Okay, a here must always be equal to 1, then we can substitute into the formula. Okay, let's go to the example. Here we have s plus 1 over s square minus 4s. So let's try to simplify the equation first. Okay, into s minus a. Our target is to get into the form of s minus a. So first, we have to simplify the denominator here. Okay, because we have s squared minus 4s. We solve by using the completing the square. So we have s plus 1 over. So to get the completing the square form, so we define first, we have b equal to -4, c equal to 0, right? So just substitute into formula, we get s plus b, -4 over 2. Okay, power 2 minus b. b we have -4 over 2 power 2. c equal to 0, right? Okay, then now we convert already. Okay, the denominator here using the completing the square. Why? Because we want to get in the form of s minus something. Okay, now we simplify this one. We get s plus 1 over s minus 4 over 2, we get minus 2 power 2. Okay, minus -4 over 2 is -2. When you put power 2, it will become positive back. Okay, so we get 4. Right, so this is not yet the s minus a, okay, because we have a2 and a1 here. So the best way is we choose a equal to 2, okay, for the in the bracket form. So a equal to 2, so up here we need to put also s minus 2, then we put back plus 2. Okay, then just copy back the original equation. We have plus 1 over s minus 2 power 2 minus 4. Alright, so our fs now is equal to, not fs, sorry, s minus 2. Okay, so we have fs minus 2 is s minus 2 plus 3, okay, from here, over s minus 2 power 2 minus 4. This is our fs minus 2. Okay, so from fs we can get fs minus 2, we can get fs. So we just substitute all the value of s minus 2 into s. So our fs is equal to s plus 3 over s squared minus 4. Okay, so from here we can find value of ft. ft is equal to inverse Laplace of fs. fs is equal to s plus 3 over s squared minus 4. So how to get the inverse Laplace here? Find inverse Laplace of s over s squared minus 4 plus inverse Laplace of 3 over s squared minus 4, right? Then we can get value is s over s squared minus 4. It is cos. It is cos. So we have cos 2t. Okay. Plus. Okay. This one we have s squared minus 4. It is sin h. Okay. And then 4 become 2 power 2. So bring out 3. Then we have over 2 sin h 2t. Right? Okay. Maybe you can try by your own how to get this form. Okay, so we get for the ft. Next, we want to find the inverse Laplace. Okay, so inverse Laplace form here actually equal to, we have convert it into the s minus a using the completing the square. So to get the inverse Laplace of this function is actually we solve by using the first shift property. Okay, which is equal to EAT FT. So A equal to, we need to refer to the A here. Okay, our form. This is A, so A here. So S minus 2, so we have declared S2 as our A, E2T times with FT. FT we just copy cos 2T plus 3 over 2 sin H 2t. Okay, so this will become our final solution. Next, we try an example that have the denominator in the form of factorized form. Okay, so we can solve this one by using partial fraction because we can split it into the simplest form. Then it will be easier for us to solve by using the table. Okay, so first I copy this one back. We have 1 over s plus 1, s minus 2 equal to a over s plus 1 plus b over s minus 2. Right, then we compare the denominator, we get s plus 1, okay, s minus 2. Okay, we combine the denominator. Then the a here also must multiply. So since s plus 1 we multiply by s minus 2, so a also should be multiplied by s minus 2. So we multiply, we get s minus 2 plus b. So s minus 2 multiplied by s plus 1, so b also multiplied by s plus 1. Okay, so since denominator same, we can take the numerator. So 1 equal to a s minus 2 plus b s plus 1. Then we use the let function. Let s can be any value. Let's say I choose s equal to 2. Okay, s equal to 2. So we get 1 equal to a 2 minus 2 b 2 plus 1. Okay, then we will get 0. We have 3b equal to 1. So our b is equal to 1 over 3. Okay, so next we have let s equal to negative 1. Then we have 1 a negative 1 plus negative 1 minus 2 plus b negative 1 plus 1. Okay, then we get 0, negative 3, 3a. Okay, negative 3a equal to 1. So our a will be negative 1 over 3. So after we get the a and b, we just substitute into the formula. We get a equal to 1 over 3. 1 over 3 s plus 1. Minus, we have a equal to negative 1. Negative 1 over 3 plus b. b equal to 1 over 3 s minus 2. Okay. So next from here, we can find value of inverse Laplace. So to find the inverse Laplace of 1 over s plus 1 s minus 2 equal to inverse Laplace of negative 1 over 3 s plus 1 plus inverse Laplace of 1 over 3 s minus 2. Okay, so for this one, we bring out negative 1 over 3. 1 over 3. So inverse Laplace of 1 over s plus 1 is equal to exponential a equal to 1. So exponential, a equal to negative 1, so negative t. Okay, plus 1 over 3. 1 over s, inverse Laplace of 1 over s minus 2 will be get exponential 2t.